Welcome to homework.
Hello and welcome. We are looking at chapter 5. Let me double check this real quick. 5, section 4, problem 5. All right, we're asked to trace algorithm 4 for certain inputs. So we're just going to go ahead. They name the algorithm, the procedure mpower. So we're going to go ahead and call it that as well. And the inputs are m equals 5, n equals 11, and b equals 3. So if I put those in the order that they're given to me in algorithm 4 on page 384, at least my page 384, we have 3, 11, 5, and this makes it look like a function, which it is. Essentially, a procedure and a function are similar ideas. So first thing we do is we check if n is 0. So we have b, n, and m. So n does not equal 0. That's the first step. So we go to the else. If n is even, n not even, that's the next step. So then we end up with that last else. We return mpower, and we use the same b. We do the floor function on n divided by 2, so that'd be 11 divided by 2 is 5.5, but we use the floor, so that would be 5. And then m remains 5. And it looks like we're squaring that. Mod 5 times 3 mod 5, all of that, mod 5, mod m. So we're just copying down algorithm 4 following the logic. So let's see if we can simplify this a little bit. Oh, I did put one of my parentheses in the wrong spot. So let's fix that. So this parenthesis here should go outside here. So let's use a different color here. So after we apply the mpower function, we do that mod 5. And that's an important distinction. So let's see if we can simplify this. So mod 5. So it looks like to deal with this mod 5 here, we're going to have to run our algorithm again. Yeah, I don't think we really have a choice. We kind of have to do our next step in the algorithm first. So we got to keep track of where we are. So the next iteration of the mpower function, so I'll put a little arrow here so I don't forget exactly what I need to substitute at the end. So this is mpower. Well, I don't need to write that again. So first I check, is n equal to 0? Nope. So n does not equal 0. Then I check, is n even? Nope. still not even. And then I'm going to return something pretty similar to what we have there. So it's going to be parenthesis m power b floor of half of 5, so that'd be 2. And then 5 mod 5 times 3 mod 5, and then all of that mod 5. All right. So now we need to apply this again here. Looks like we're going to apply this 2 more times. So hopefully this simplifies a little bit easier than it looks like it's going to. So n still doesn't equal 0, n is still not, oh, n is even now. So I guess we just don't have to use the floor function. Oops. N is even. So we're going to return m power 3, 1, 5. Oh, I forgot my squared on this one. Squared mod 5. All right. Now we have to do this one. This should be our last, second to last one. So um, plugging into there. We go through and doesn't equal 0 yet. It's not even. So we go to that final else statement. So we're going to return m power 3, 0, 5 squared mod 5 times 3 mod 5 mod 5. And then if we look at this, the algorithm says we return 1 for that. If we look, if n equals 0, return 1. So now we can kind of start working our way upwards again. So if I plug 1 into here, I have 1 squared mod 5, which is 1 mod 5 times 3 mod 5 is going to be 3 mod 5. All of that mod 5 is going to be 3 mod 5. So now I guess I'll use red. So plug 1 into here. That gives me this. This gets plugged up above. So 3 squared is 9. Mod 5 is 4. Four squared is 16. Mod 5 is 1. 1 times 3 is 3, so that gives me 3 again. 3 squared is 9. 9 mod 5 is 4. Times 3 is 12. Mod 5 is 2. And so that should give me a final answer of 2. And that is correct. So a lot of work, but we're done.